Good.
My page should actually double
Good.
how much notes I
All right, hey, we're only going to take a few notes today, and it's going to be based on graphing. And so if you have your graph paper, have that out too. We're going to do a couple problems where we're going to talk about graphs today.
What are you doing, Mr. Ward?
What?
The outline is due tonight. Yeah, I know it's due tonight, but I haven't done it yet. Or did I do it?
No, I am so excited.
I don't think Megan has
The game, I
when I was checking yesterday, when I your outline, and I was like, oh, awkward, maybe I should do that.
What? No, I put that up. I told him. I brought it up and then she was like, do it.
Sometimes they leave.
Oh, I'm excited. Yeah, the game, I literally was kind of.
Anyway,
No, I get so.
will you help me
like,
choose what to do my outline on?
yes, and wait, caramel, please.
No, man. Okay.
What? You're not allowed.
Okay. Okay.
Just, oh my gosh, Lord.
Okay.
Really quick.
Nope. All right. Today we're going to take a few notes. You need to have your notes out ready to go. What we're going to be talking about today is
I don't know.
today we're doing vertical asymptotes, horizontal, and slant. We haven't talked about that. We've been talking about how to graph functions with end behavior, how to talk about the turning points and x-intercepts and y-intercepts. We have to put it all together, and now we have to talk about is there a limit to a problem where it won't cross a certain boundary, and that's what we're going to look at today.
I have a question. I have a speech that's due at midnight tonight. What should I write it about? Or do it?
It has to be something that affected American history.
Mr. Ward. I'd say that vertical asymptotes have greatly affected American history.
I don't know. We're talking about
Non-Euclidean jump.
for the word like
Wait, what are we doing?
propaganda. The propaganda for word.
For war? Which war?
Vertical, horizontal, asymptotes, slant.
Okay.
I'm talking
about
And then an asymptote?
I don't think that I would get 100% for that.
Lucas wrote about the NBA and got 100%. So
Okay, well, Mr. Ward and the NBA are.
I wrote about 9/11 and how it's
Mr. Ward
affected.
actually
Let's
done
go.
something.
All right. Hey, here's the first problem I'd like to do right now. We have two problems that I want you to go through.
They don't know what Mr. Ward is.
Okay, two problems. Here we go.
okay.
When's the homework due? Thursday?
We're not getting homework.
What's the point?
Mr. Ward actually has a website that's for the world.
I read my book today.
It's for the World Wide Web.
www.
I feel kind of bare because I don't have my actual notes. I'm excited.
Website.
Okay. Here, but
Have you seen the thing where it's like,
Why? Come on.
sit.
I am.
Incorporation.
Okay. All right. Hey, I got a problem written on the board. I'd like you to write it in your notes. And if you have your graph paper out, you can put it next to your graph. If you don't have a graph, it's fine. You can just draw a rough sketch what we're about to do.
You don't have more graph paper?
I have more graph. Do you want graph paper?
Like you really don't
Does
want
it backward to a positive 3 and a positive 2? Hey. 5
Really don't want me to do my notes?
Not 2.
Why did you come to class without them?
Because I was in college bio. You think we did something there?
Well, why wouldn't
I
we
don't
do
think
something?
Because you're told to make way, Mr. Ward.
Anyone want?
You have to
I have a
mention
Word.
word.
Mr. Ward, can I get something just not
I would like
why'd you give me that?
Anyone else?
Mr. Graham needs one.
Just give me one graph.
Mr. Ward, I would like to point out that I'm a fan of calculus.
Okay, good. All right. Hey,
Actually pretty good.
okay. All right. This problem has vertical, horizontal asymptotes. There is an actual limit to it. It does have zeros and y-intercepts and x-intercepts. The reason why we have it, is that the problem is here, is that there's going to be vertical asymptotes. Vertical asymptotes are made by whatever solves out the bottom. That's how you know about vertical asymptotes. Okay, so whatever roots are for the bottom of a fraction, like a rational function. Rational have fractions. Whatever makes the bottom 0, that would be an actual vertical asymptote. Now, if it can simplify, if it simplifies, then you wouldn't have one. There would actually be, it would be continuous over that spot. But for right now, there is two numbers that we can throw out right away. Now, the top is x-intercepts. So these are the zeros. The x-intercepts are whatever makes the top 0. So that's basically how we do it. Now, for horizontal asymptotes, it depends on if the top is bigger than the bottom, if they're exactly the same, that sort of situation where if there's a horizontal asymptote. On this one, the bottom is actually bigger in power than the top. So what your book always says is that if the bottom is bigger than the top in power, you're going to have a horizontal asymptote at 0. That is one of the hardest things to kind of talk about is the horizontal asymptotes, because there's 3 situations. It could be at a certain number, there couldn't be one at all, or if the bottom is bigger in power, so the denominator
What is that? It's supposed to be an arrow.
denominator in power or exponent is larger than the numerators.
Which one's on the bottom?
Denominator.
Thank you.
Denominator's power is bigger than the numerators, then you have a horizontal at 0. In this case, the bottom is bigger than the top, so in theory, we're going to have this horizontal asymptote right here. Now, the only tough part about a horizontal asymptote, it's not rigid. What I mean by rigid,
It can cross over.
yeah, we can cross over it, but it's like the ends.
Selectively permeable membrane.
Just like the bilipid,
I know.
just like the bilipid in our cellulose.
That was good.
That was well done. All right. Now,
Why don't we write that down?
I don't know how you can do it.
Selectively permeable membrane.
I better write it down.
You better just write it down under horizontal. I like the term use. All right. Now, as he's writing this down, what I want to make sure of is that the tails on the outside, the tails will hug against the zeros. So, so the idea is that on the outsides here, the tails will at some point come really close to 0, 0 because the bottom turned out. Oh my goodness.
Is that X?
All right, I immediately regret this decision.
Why? People are gonna write this down. Who is all gonna write this down?
Warren's
This is a boy, please don't quit making fun of
Yeah,
him.
me.
I'm not making fun of him. I
Yes,
just
you are.
immediately regret the decision.
Exactly, that's making fun of him.
This is a bully-free zone.
I think.
Membrane.
Selectively permeable membrane. I like it. All right, we'll call it that from now
That's the
on.
biggest
I'll
membrane.
put that on the test.
Yeah, I'm confused.
All
That
right.
is the biggest membrane has ever been.
Okay. So the idea is here is that we know we're going to hit 0, 0. Now the problem is I don't know if we're going to be above it or we're going to be below it, you know, or which direction that will be. Maybe it'll be the opposite where it'll hug against it this direction and come down from this way. Like, we're going to have to look at that at a later time to see
Wait,
kind of which direction
If the
it's going.
denominator is greater than the numerator.
Yeah, if the denominator's power is larger than the
Then
numerator's,
it's at 0.
it's at 0.
weird, Roxy.
And it doesn't matter what it was. Now, we're going to do one more example after this where they're exactly the same power, and that's where it'll have a horizontal at that specific number. We'll look at that. Okay, now that we know we have vertical asymptotes, we have 2. We're going to do those here in a second. We do have an x-intercept. We will have to find the y-intercept here in a minute. Then we can go on from there. So here's the idea. We're going to find all these asymptotes first. Vertical, what we're going to do is we're going to take this denominator and we're going to factor it apart. Well, it's a trinomial rule. And we factor it apart. It's x and x, plus and plus,
I
3 and 5.
I don't want to be.
Okay, so here's my numbers. Okay? So the idea is that now that we have my numbers done, alright, now that we have my numbers done, what are the roots that make these things zeros?
-5, -3. Go.
Good. Those are where my vertical asymptotes will be. So -5,
You know what I mean?
that's right here. 1, 2, 3, 4, 5. Alright.
What?
This is the funnest way ever.
I don't know. How are we supposed to get out of tag?
Okay, hey, will you stop talking, guys? It's really annoying. All I'm hearing is you talking.
Come on, Josh.
Okay, so -5, I have one vertical asymptote. -3, I have another one. I can still hear you. It's annoying. Alright.
I thought you told us last year you were deaf.
I can hear you when you're talking.
You just can't
That
have
doesn't make
words.
I want to hear the
I'm
words.
deaf, but I can hear you when you're talking.
I can't hear what you're saying, but I can hear the mumble in my background. I just want to use my mind.
Someone was visualizing you figured out they were same line.
Okay, alright. Now, we know the tails are flattening out. We know that we have vertical asymptotes in those 2 locations. The x-intercept is whatever makes the top equal 0. So in this case, whatever makes this equal 0 is a -1. And again, if you needed to factor that, you'd factor that apart. So -1 is where we're hitting an x-intercept. That means that there's no other x-intercepts, so we're probably not crossing the x-axis in these other locations. Okay? So that means like in this middle area, here, I'm not crossing the x-axis. So somehow it's probably turning around or staying below.
How do we find out?
Over here, we're gonna see that here in a minute. Over here could be up above or down below because there's no x-intercepts. And over here, somehow I'm going through this. I don't know how it's working. So we're gonna look at that. Okay? Question?
No, I'm just.
Okay, you got your hand right in front of the camera, just saying. Jesus. So, alright. Now,
Somebody wants to see your big meat paw.
hey, bully for
Dude,
time.
no.
Alright.
He laughed, he was like,
That's not even.
Mr. Ward, you
you roast me the other day.
That's not even bullying.
Nobody wants to see your big.
Alright.
Mr. Ward, you bullied me and didn't tell yourself that.
You know those hammers?
Mr. Ward, I'm a mandatory reporter. I have to say that.
Alright.
That you're bullying.
I'm not bullying.
Mr. Dr. Jack Johnson is a mandatory
Stop.
reporter. I will call him.
Just stop. Alright. Now, okay, we have my x-intercepts. Y-intercepts is the next one I have to do. Y-intercepts is when I plug in zeros into all these functions. 0 squared plus 0x plus 15. And so it looks like we're gonna get 1 over 15.
You know what that means?
That's my y-intercept. That's just a decimal. It's it's above the y-axis, so it's here. So I can kind of tell like where this thing's going. It's probably coming from down here and kind of coming up and through.
That's .06.
And kind of doing this type of thing, where it's gonna hug up against 0. Just because of where that y-intercept was, it was positive. All right, questions at all about y, x, and the asymptotes?
No.
Okay, we don't have slant, and I'll explain that reason why.
Lord, what the heck is up there? Oh my god.
Okay,
And wrote it too.
okay, so, real quick here, now that we have these, the next thing I'm gonna do, next thing I'm gonna do is we're gonna try to figure out where the graph goes. So the question was, how do we know where the graph's curving? How do we know the actual plots?
Plug it in.
Yeah, basically, what we have to do here is we're gonna have to take my function and we're gonna have to plug in values that are in the selected regions. What I mean by that is that there's 3 regions. There's this region right here, I'm gonna call this kind of the first region here. This is gonna be my second region and third region.
Tyler, stop talking.
So, okay, so here's my 3. Hey, stop, move, now. Probably 4 times, move. Okay, now, what we're gonna do is we're gonna plug in numbers now into each of these regions and figure it out. So in the first region, my x's that I'm over here, I'm gonna plug in -12, -10, all the way up until I get to about -5-ish. So I'm just gonna jump, I'm gonna go -7, -6, -5.5. I just wanna get as close as I can to see where that thing is
I mean, you
going.
can do
Yeah, but don't you
-5.
only need to do like 3 of them and then you can see where it's going?
Yeah, but I just need to see like I mean 3 would probably work, but I just wanna get as close as possible to see kind of which way it's hugging, which way it's going from there.
If it's gonna cross.
It's definitely not crossing, because we know that we only have 1 x-intercept, so we know that. Alright, now, there's the, okay, this is region number 1. Region number 2. So, region number 2, I'm gonna plug in 3 numbers, get that hand out of there. So,
Get your meat paw.
region number 2,
Stop talking.
-4.5, -4, -3.5, and I'm gonna go with -3.1. I know that I'm not using 3, I'm using 4. The reason why is I just want to see, is it like a perfect U shape? What is it kind of doing in that general region? Because maybe it doesn't actually like turn perfectly. Maybe it's like off center, so it actually turns like over here somewhere. So I can kind of see. Just plug in 4 numbers. Now the third region, these, I really already have 2 dots. I need to put 1 dot like over here and 1 dot over here to kind of see what's happening. Because I know the y-intercept, I know the x-intercept. I just need to see if my numbers to the left of it, like at -2.
Don't they always hug the asymptotes though?
Yeah, on the horizontal, they always, the tails will always hug those, if you know you have a 0. If you don't have a 0 like asymptote, they're probably going to negative infinity and positive infinity. They're going up. So that's just kind of like just a general thing that I look for. Okay?
Can you stop talking?
All right. What I need right now is I need people with calculators. Stop the water bottle.
I have one.
Okay. All right. So, okay, hey. So, real quick here, I'm going to assign you. You're going to plug a -12 on the problem.
Give me 10, 10, 10, 10.
I don't know what that
-10, plug into the calculator. -7, -6, -5.5 if you have a calculator. -4.5, -4, -3.5, -3.1, -2.
You need mine?
Justin, I'm gonna
I don't
go
have a calculator.
Am I
10,
negative
go
10?
back there.
My negative 10 bar.
Yeah.
I said,
So go grab a calculator if you don't have one. I want to know this number.
I got it.
Plug in
That's
this.
still good, that's funny.
Which number you got?
-6.
Okay.
Because I left it in there. 4, 6.
Sydney, can you move? I took it from the back.
Hey,
Get your hand locked out of the camera.
I'm -7.
Sit.
I had to
Sit.
get
Once you have your calculator. We don't need to be yelling.
Mr. Warren,
Okay. For those who are typing in numbers.
I'm -7.
Hey. Okay. Whoever's typing in numbers, you're typing your number that I told you into both or all 3 X's. You're figuring out the top, and you're going to divide whatever the bottom is. You probably should find those numbers separately, then divide top by bottom. Because I know that people type it in wrong if I tell you just to type it all at once.
Keep tapping on
Okay.
What number did you tell me I was doing?
You had -2, I think.
I'm -7.
-2.
You told me to
Fine,
do
10.
10.
Do 10.
It's 0.056.
Oh.
Okay, 10. Say it again.
0.056.
Okay, so 10 is at 0. Point what again?
0.056.
Okay.
Okay, outline.
Okay.
I got
Negative
it.
12.
Negative 12. Negative .175.
175. Okay.
Mine's -0.055.
Negative .055.
Yep.
Negative.
.75.
Mr. Ward, you're doing it for the wrong number. Didn't you say they were negative?
These are negatives that they're plugging in.
But you plotted it on the right side, didn't you?
Oh, these I haven't plotted these yet.
Yeah, but my.
Justin told me his was 10.
Oh, I thought you did.
His was 10 earlier.
I thought his was
No, he went out of order. So okay. Who had negative 4.5? Was that Nicole? No, you had. Was it?
I had 6. Oh, I forgot.
Leah,
Let's
you
go
had negative 4.5.
No.
Swift. 4.6 repeating.
No, I don't think so.
4.6 repeating.
Do you think your fish likes Pop-Tarts?
Okay, you had negative 5.
He's almost dead.
What do we get?
What's that?
Yeah, that's what my fish looked like. I
That one was me.
didn't like
I
that.
don't think I hear either.
Oh my god, he's dead already. Dude.
Hey, go sit. You already know. Go sit.
Homecoming prank.
Is he dead?
Someone stole your fish.
Yeah, I love that.
Where's Mr. Ward? Why are some of them
Hey,
negative and some
hey,
of them aren't?
Just stop. Stop.
Yeah, hey.
No, I'm not answering your question. Put your hand up. I'm not going to answer your question. So,
Yeah, just, I got it. Just ask
okay.
someone else.
What do we got?
I'm not done telling in.
Okay, next one. What do we got? Which one are you on?
4.
You're on 4. What do you got?
3.
3. Okay. Negative 3.5. Who's got?
0.
What's wrong? How is going on?
Like that?
I'm not sure what you keep
Okay.
saying.
Who's got negative 3.1?
I don't know if it's right. 11.05.
Say it again.
11.05?
Holy cow.
Oh,
Okay.
shit.
That's fine. Okay, who's got negative 2?
0.2.
0.2? Okay,
Uncharted too.
0.2.
There's a ghost.
Yeah, this is weird.
We're kind of all over.
Okay, I agree with these, except for this one, I'm a little concerned about. This one probably should have been negative.
Well, it might have, I don't know. How do you tell if it's negative or not on a calculator?
Because I
If there's a good old.
I shouldn't have crossed the x-axis there.
Here, I'll
Mara, you seem pretty secluded.
No, I'll do it. Give me a second.
You seem rather secluded up there.
Negative 3.1.
Negative 29.
No, that just makes sense. It's got
Mr. Ward, I got 0.2
Wait.
Is this not
Yeah, it's not
No, it can't be
negative.
negative.
It is funny.
Got it.
Negative
No, it would
6.
be because it
Let's
makes
just break it down.
squares.
Okay, you do the top. No, I did it right. I got it right.
Dude, it's
Okay.
negative
Let's-
1.6666.
Yeah.
That's negative 6 plus 1 is 5.
2.1
Negative 5.
Negative 5, right?
Divided
And
by
then 36 minus
0.19.
48 plus 15.
11.05.
36 minus 48 plus 15 is 3. So negative 5 divided by 3. Shoot. 3 equals negative 1.6666. That's not what you get when you just type it all in at once.
Well, because you
Because
did
I
it
told you
wrong.
not to do that.
Wait.
but You don't.
I put parentheses on there.
No, she didn't.
No, actually, mine's not negative either.
Okay. Hey.
I think I told you to do the wrong thing. So I didn't put the negative 10 squared in parentheses, so I gave you the wrong thing.
Sometimes.
No, mine's .26.
Is it Coca-Cola?
Not negative though.
Wait,
It
I have
has to be negative.
It has to be negative.
How?
Because it can't cross the x-axis again, bro. Come on.
bro.
Bro.
10.
Bro.
Negative 10 squared is 100.
Comes faster.
Plus
Never.
60. Wait, minus. Not
Okay, hey, I can already tell you right now, by just hearing the numbers, this is what we're having, because the one that really made the difference was negative 5.5. That was a negative 29 something. That's a really low number down. In the middle, these are all
It is
positives.
negative too.
So it's positive, so it's going up. I just don't know where it's dipping down towards.
We
And
gotta
in
figure
the
it out.
middle, this part I'm concerned about because the numbers didn't make sense. I don't know if it like crossed over and came back up, because one of the numbers we had at negative 2, somebody said it was 0.2.
That's what I said.
Okay,
Okay,
so
well, mine's
I don't know
actually
if it's
negative
doing something like
0.26.
this,
I don't think it's allowed.
where it's like bouncing down. I don't understand how it's doing through that. It's got to be coming from the top.
Can you Desmos graph it and
So,
tell us what it looks
You
like?
made a extra special
Hey, you were
equation,
right, it
that's
is
what happened.
negative. Word.
I made an extra what?
Special equation. You
Okay.
just made one that no one's ever done before.
Yeah.
Yo.
So I'm not holding
Can we
it.
Desmos
Okay,
it?
we're gonna type this in the graphing calculator so you can see
Or
this.
Desmos?
Okay, I'll just type in the graphing calculator. All right, real quick, these are the parts we need to get used to. Now tomorrow we're definitely going to be Monday, whatever. Monday we're gonna be typing in stuff for slant asymptote, and we're gonna be looking at the special cases of horizontal asymptotes. We're gonna be looking at that. You are getting an assignment Monday. It'll probably be due on Wednesday next week. So you're gonna have to do some.
Quick turnaround.
So yeah, quick turnaround.
Are we
You're
the
gonna have to make
dumbest
sure.
calc class you've
So-
ever taught?
What?
Are we the dumbest calc class you've ever
Be
taught?
honest, just come on.
Right now. So.
Which one is home like
Mine actually was.
What?
This way I don't like
I hate home.